In this video, we're going to talk about multicast service reflection on the Nexus 9000. Now, before going into multicast service reflection, let's do a quick recap on network address translation. Now, using NAT, an operator can translate the source IP, the destination IP, the source port, or the destination port of an incoming flow. In a typical Unicast NAT, the incoming pre-translated flow and the outgoing post-translated flow are both unicast. And with Multicast NAT, the pre-translated flow is typically multicast and the post-translated flow is another multicast flow with a different IP address. Now, what multicast service reflection does is it provides the operator an ability to take in an incoming unicast flow and translate that into a multicast flow, or take in an incoming multicast flow and translate that to a unicast flow. Now, before this feature was implemented on the Nexus 9K, our customers were still implementing some flavors of multicast service reflection, but it was typically done outside the network itself. Now, while that worked, it did have a few limitations. One was performance. Couldn't do line rate, especially when most of the flows are high bandwidth video, as an example. And the number of translations, right? There was definitely a limit in the number of translations these external devices could handle. And of course, an external device just for that particular functionality also meant additional expense, both CapEx as well as from an OpEx perspective. Now, the biggest advantage of using the Nexus 9K to do some of this functionality is, one, you can do all of this at line rate. And today we have switches that are 400 gig enabled, so you can go all the way from a 100 meg switch to a 400 gig switch and do all of these service reflections and network address translations without impacting performance or throughput. And from a scales perspective, the Nexus 9K can support up to 2000 translations at any given point in time. And finally, you're not leveraging the Nexus 9K for just this one functionality, right? Along with the fact that it can route unicast flows, multicast flows, onboard several other applications to run on this box, this feature allows you to use the same switch for this new functionality, right? So you get better return for your investment. Now, having given you a background of what the feature is and its implementation on the Nexus 9K, let's look at what problems does this solve for our customers. The first use case involves a scenario where there could be multicast sources that's outside your own network, and you're going to ingest those sources, but occasionally you could run into an issue where the IP address used by those external multicast sources is overlapping with the IP address used by some internal multicast sources. All I have to do is enable multicast address translation on the border switch that can translate, in this example, G1, G2, G3 coming from that remote arena into G11, G12, G13 that any receiver within your fabric can dynamically subscribe to. Another use case is content distribution. Now, this is a very common workflow, especially in the media and entertainment vertical, where you could have a customer that's producing content, provide that content to a bunch of third parties where it is distributed. Now, using Multicast NAT, you could take a flow that's S1G1 and translate it to a different address that third party is subscribed to or listening to. So the flexibility with this approach is that you could route different source, groups to this third party without the third party having to explicitly request for those groups, because all of these translations can be controlled by the operator managing that demarc switch. And then this functionality can also be used for destination control. As an example, say you had this destination, which is that TV monitor, that is not capable of sending IGMP joints. But you have to route different signals or multicast sources to that destination at different points in time. So over here, I can use Egress Multicast NAT on that switch that's connected to the destination. So at time t0, you see S1G1 being translated to S, G and sent to the destination. And at a different point in time, you could have the source S2G2 being translated as SG and sent to the same destination, and so on, right? So you see how without the destination requesting for a specific flow, the operator can still route different sources to that destination, leveraging Egress Network Address Translation for Multicast. And then there's also a use case where we've seen customers having to transport these multicast signals to destinations that may not necessarily understand multicast, which in our case is the public cloud as an example. This use case is very common for both customers in the service provider, media and entertainment vertical, as well as some of our financial customers as well that are heavy multicast users. Now, if they want to use some services provided by the public cloud, often these sources were converted to Unicast externally and then sent to the public cloud. Now, with this feature being supported on the Nexus 9K, our customers can convert a multicast flow to unicast flows. In fact, create multiple copies of that same flow and ship it to the public cloud. Then along with public cloud, I've also seen customers use this feature when they have different facilities that are interconnected by a WAN network and say the WAN does not support any multicast. So this feature helps the operator convert that multicast stream to unicast, and then that can be transported anywhere externally within the network or to the public cloud. And then to complete the feature, we also have the ability to take a unicast flow and convert it to multicast. And the use case in this scenario is that, say you have a user that is uploading a video on a customer server. The video coming over the internet is typically unicast. So this Nexus 9K, which is connected to the internet, leveraging this feature of unicast to multicast address translation, can convert this signal into multicast, and then anyone within the network can simply subscribe to that signal.